So we left off at the end of class on Wednesday talking about validity, reliability, and power, and the observational definitions that we will need before we can actually begin a study. Well, after we have developed this operational definition, and we've determined that it's valid, and we've determined that our measurement is reliable and has power, then we have to decide where we would like to do our observations. And we have two options here. One is in a naturalistic setting, and the other is in a laboratory setting. There are pros and cons to both, as there are with every aspect of psychology, but you really have to choose your setting based on what type of question you want to answer. Do you want to know how a specific behavior occurs or why a specific behavior occurs in the natural environment, or do you just want to know if one occurs at all, period? And that could be more of a laboratory setting. So it depends on the question that you're asking. So first, we'll look at naturalistic setting, and this is really an unobtrusive observation of people in their natural setting. So what I mean by unobtrusive, and these are some of the advantages, is that it gives you a realistic picture of how these people are going to behave when they don't think that they're being watched. It removes this observer effect, the idea that you're going to act differently if you think that someone's watching you. So that is good. However, there are disadvantages, and that is that not everything can be observed in a natural setting, because some things don't always occur naturally. If you wanted to measure, if you wanted to observe aggressive behaviors in someone, if in a naturalistic setting, you would have to follow them around, wait for something to happen, and then see how they reacted to it. Or you could just put them in a laboratory setting, have someone act aggressively towards them, and then see what their aggressive reaction might be. Other times, not everything can be discovered in a naturalistic setting. So in a naturalistic setting, you can remove the observer effect by having the observer, having the researcher stand away and not really, and go unnoticed, basically, by the person that they're observing. However, some things you must have direct interaction with that person. You need to know backstory. You need to know demographics or finance or past history and past psychological history of their relatives. And for those things, you're going to have to ask them. And so naturalistic wouldn't be the best for that. And then finally, you can't control your environment in a naturalistic setting. So if you want to observe what people are doing, how many hours they're spending outside, and one day you follow them around and it's 75 degrees out and sunny, and the next day it's raining, well, you're not going to get a very reliable data set to look at. And in addition to that, other people that are trying to replicate your study in the future won't be able to recreate the environment that you were specifically using to observe in on that specific day. So it's difficult. It's difficult not only for your own studies, but it's difficult for future studies as well. So for this case, people will often use a laboratory setting. In a laboratory setting, you have more control over the environment. You have 99% control over the environment. You can change the room temperature. You can change how far away people are sitting from one another. You can change the volume of a stimulus if you're playing a stimulus. And so you have a lot more control over what's actually happening. But on the flip side, on the negative side of that coin, you get these observer effects or these demand characteristics that people in an observational setting will behave how they think that you want them to behave. So if they know that they're in for a study on aggression, they may behave more or less aggressively in order to give you the results that they think that you want. And so those obviously will not be accurate results. And this comes in with the observer effects. In the naturalistic setting, when the observer can stay away and go unnoticed by the person they're observing, this can't occur in a laboratory setting. You obviously know that you've been brought in to be observed. There are a number of ways that around this that work particularly well with small children, but very few with adults. In addition, observer bias is under naturalistics, but it should also be under a laboratory setting. So an observer bias occurs in all types of settings, and this is also called a confirmation bias. But it's basically that the researcher is ignoring any information that contradicts their own ideas, their own biases, or the hypotheses that they created in an attempt to prove their hypothesis is correct. And so obviously that you're coming up with false data or even tainted data. And so this occurs in a number of ways. One, that they are not being ethical and that they are only writing down things that is going to be relevant to their study and to help their hypothesis, or that they have expectations that cloud their judgment and they often interpret their observations or the behaviors of other people, they interpret them in a different way based on what they want to happen or what they think should happen. So, for this reason, in order to avoid demand characteristics, you often might want to manipulate behavior or look at behavior that can't easily be demanded, that people can't easily try and change their behaviors to. So something that's out of voluntary control of the participant. When we talked about fear, we looked at the dilation of pupils or increased heart rate, as well as sweating. These are all physiologial measures that can't be changed, and it's going to happen no matter what. And so that's a good way of overcoming both the observer effects as well as the expectations or the observer bias that we could see in either one of these settings. A few other techniques, you may bring a participant in and give them a cover story. It's technically lying to them up front. You tell them the truth later, but you lie to them up front and you mislead them based on the reason that they're there. So if you want to study aggression, you might tell them that they're there for some financial study or marital happiness study, and so you kind of throw them off. In the same way, you could use filler items. If you're administering a questionnaire and you want to look at aggression, you may throw in a myriad of other items that cover an entirely different topic to really throw the participant off, throw them off your scent, off your case. In addition, double-blind observations. These are most typically seen in medical studies when they're trying out new drugs. So oftentimes people will, one group will get the placebo and one will get the actual drug. Well, in order to avoid this observer bias, they will create these double-blind studies where neither the participant nor the observer know which is the placebo and which is the actual drug. A third party that actually has nothing to do with the experiment will be the one that actually knows which one is which. And this can reduce those biases. Participant observation, this is something that would typically be done in a laboratory setting. And this is usually seen in the way of a two-way mirror. It works best with children, obviously, because if you bring adults in and they see one of those mirrors, they're going to think, oh, I bet someone's on the other side observing me. And they're usually right. But with children, it's a bit easier, and you can observe them in a natural play environment, even though it's in a laboratory. Even though you're having that control, you can still let them play in an environment and not have them feel like they're being watched. And then finally, we talked about the observational measures. So, moving on, now that we have developed a study, we have come up with reliable measures and a valid operational definition. And now we know that we want to have it in either a laboratory or a natural setting, and we conduct our study. Then what? Well, then we have to analyze our data. And we don't just look at the raw numbers when we're analyzing data. It's a bit trickier than that. We want to use mathematical methods in order to organize, summarize, and describe what is actually occurring. So we take our raw numbers and we put them into a inferential and descriptive statistics, and this helps us to determine what is actually occurring in a more statistical way than just saying, oh, well, this kind of looks to be the path of things. So statistics are often represented in graphics, in graphical representations, and this is just to give people an easier way to read or to understand what is going on. And there's a number of ways that this can happen. One is a simple frequency distribution table. So if you want to know how many hours do you exercise a week, or do people exercise a week, then you might give them a scale of 0 to 7, and then you ask people, and you write down the frequency at which people answer which number of those hours. And so this is just a very simplistic way of looking at the distribution. Another way, which you may have learned about in some of your previous math classes, is a histogram or a bar graph. And this will give you, this is just, it's the same information, but it's just given out in a way that's more pleasing to the eye, that's easier to understand. And then finally, this is the most frequently used in psychology. And as you can see, it is a point and line graph. So this gives you an idea of the pattern of exercise in the 30 people that were asked over time. It's the same information that you saw in the frequency distribution. However, it is, like I said, more aesthetically pleasing to the eye. So let's take that. What then do we do? What can we discern from this line graph? Well, depending on the arrangement of the lines, we can determine whether or not something is positively or negatively skewed. So, as you can see with the graph on the left-hand side, this is a skewed distribution with a positive skew. The hump, the greater number of people, are on the left-hand side. Don't ask me why that is, that's just why it is. It is a positive distribution. The more scores are on the lower end of the scale. So, positive skew, scores are on the bunched towards the lower end of the scale. Alternatively, you can have a negative skew, in which your scores are going to be concentrated more so on the higher end of the scale, more of the 5 hours, 6 hours, 7 hours a week people that exercise, people that must love exercise. But this will also give you a very quick visual aid of what actually is happening with your data. Additionally, there is a normal distribution. So the previous two were skewed, as a great many data points will be. But oftentimes you will come with a normal distribution. And this is also called a bell curve, for no other reason that the shape represents the shape of a bell. And what this means is that the majority of your distributions, the majority of your people, are going to be concentrated in the very middle. They're going to be right there in the middle. You're going to have some on the end and on each of the ends, but most of them are going to be right there in the middle. It's the average. And so if you think about it in terms of exams, say exam 1 for this course, most of you will fall right there in the middle of that bell curve, which means that most of you will get 70 to a 75 average, where there will be some A's over here and some F's over here, but most of you are going to be right there in the B and C range. So, food for thought. But this shows that 50%, half of the people, so in your case there's 40 of you in the class, 20 of you will fall above that average and 20 of you will fall below it, below that center line. In a normal distribution, all measures of central tendency are the same. So the mean, the median, and the mode are all the same. And these are all three measures of central tendency that we will discuss. So central tendency, can't say it, is used for putting information in a distribution, so in one of those plots, into a more compact form. It summarizes it basically into one single score. And so you're looking at what is most typically happening in this single score, where most of the scores fall. And there's three types of central tendency: the mode, the median, and the mean. and we will look at snapshots to probably review for most of you what each one of these means. So, going back. So, if I want to look at the measure of central tendency of how many Snapchats people send per day, and I collect data from 20 individuals, so half of the class roughly. A good chunk of you say 0. Maybe you don't have Snapchat. Get it. 3 of you said 1, and a good number of you said 2. 3 of you said 3, and only 1 of you said 4. I would be like way off in the tens, probably. But if you want to look at measures of central tendency for this specific statistic, your mode would be the most frequently occurring score in the distribution. So in this case, it's going to be 2. The median is the score that divides the frequency distribution in exactly half. So if you put them all in chronological order and numerical order, or whatever it is that you're looking at, then you count in from both sides to exactly half. That's going to be your median. Notice here that the mode and the median are both 2, the same number. And then your mean. And this is when you would add all 20 scores up and then divide them by 20, the total number of scores that you took in. And your mean is going to be 1.5. Notice that it is slightly below the mode and the median, but they're all very similar. It's very, very close. Whoops. So, central tendency. It's great if you want to very simply and in a very compact way describe what's going on in your data. But we run into problems because sometimes our measures of central tendency are really misleading. So here's a good example. We're looking at income per family in the thousands of dollars. So, all right, say you're sitting in a cafeteria and the average income in the cafeteria is $65,000. Seems like a lot to me, but it's really not. But so your average income in this cafeteria is $65,000, and that's about where your mean, your median, and your mode are going to fall. But then over here with this guy, that's Bill Gates. It's not, because he makes more than that. But it's Bill Gates. Say it's Bill Gates, and he comes into the cafeteria. Well, what is that going to do to your mean? It's going to shift your mean so far away from your median and your mode. And if someone were to ask you, well, what's the average? And you give them that mean, that's not a very representative idea of what the majority of people in that room are actually making, because Bill Gates is over here throwing it off with his sacks of money. So be careful when you're looking at measures of central tendency. Make sure that when you distribute that number to someone, that it actually means what they think it's going to mean. So, in addition to looking at the measures of central tendency, we also want to look at variability. And so these are the two major kinds, both central tendency and variability are the two major kinds of descriptive statistics. So variability is basically just how much spread there is on a distribution score. So all of these scores and how spread out are these scores. Now you can see by this graph that the green scores are more compact. More of them are going to fall towards that measure of central tendency, towards that center line. However, in the red scores, it's the same length, but it's flattened out, and so more people are going to be able to be on these ends, and they're going to be further away. They're going to be more variable from that center line, from that main line, than are people in the green scores. So note that both of these distributions are not skewed. They're neither positive nor negative, as in the previous two samples. But this is an example of a symmetrical distribution, and even symmetrical distributions can have high variability from one to the other, even though they both have measures of central tendency. So that's why we need both variability and central tendency to give us this overall idea of what's actually happening. So, variability, and how much scores differ from one another. moving on to correlation, we're still in descriptive statistics, but moving on to correlation, it has been emphasized that in discussions of correlation that causation does not necessarily equal correlation, and vice versa. Correlation does not equal causation. But let's talk a little bit about what correlation is in detail. Basically, when you say something is correlated, that means that there is a relationship between two variables. So there might be a relationship between swimsuit sales and, summer. Those two have a relationship. They are related in some way, but there's different forms of relationship. So let's first look at positive correlation. And positive correlation is when two variables systematically change in the same way. They're either both increasing together or they're both decreasing together, but they're doing the same thing. It's either, we're both going up or we're both going down. You're not going opposite ways. So, in this example, the amount of energy level that a person has is positively correlated with the compliance of their yoga routine. The more energy they have, the more compliant they will be. The less energy they have, the less compliant they will be. And you can see that based on this graphical representation. Don't forget, they're both increasing together and they're both decreasing together. Because if I don't have a lot of energy, I'm definitely not doing yoga that day. On the other hand, there's negative correlation, and this is how two variables systematically change in opposite directions. So this can be very confusing. Oftentimes, people will confuse positive and negative correlation, thinking that positive, they both increase, and negative, they both decrease. But that is not the case. Once again, positive, they increase together and they decrease together. Negative, they do the opposite of one another. And so, as in this example, as cigarette smoking increases, the compliance with the meditation routine decreases. As the compliance with the meditation routine increases, cigarette smoking decreases. So they're doing very opposite things from one another. One thing goes up, the other thing goes down. You can think of it as also the height above sea level and temperature. The further up the mountain you get, the lower the temperature goes. Those two are negatively correlated. As another example, as the number of Snapchats you send increases, the battery on your phone decreases. Negative correlation. The amount of time you spend on Facebook, as that increases, the amount of time that you actually study decreases. A negative correlation. So, those two are both negative and positive, just as there's a negative and positive skew. There is also a non-correlation or no correlation whatsoever, and that means that there is no relationship that exists between two variables. In this case, no relationship exists between level of coping and the compliance with an aerobic exercise. So those two, you could do one a whole bunch, and you could exercise all the time, but it's not going to increase your level of coping. It's not going to decrease your level of coping. They are not related whatsoever. So, if we determine that there's a relationship based on this graphical representation, so we know it's a positive relationship or it's a negative relationship, but now we want to know how strongly those two are related to one another. Are they just kind of related? Like when one goes up, the other one kind of goes up a little bit, and when one goes down, the other one kind of goes down a little bit? Well, no, we want to know an exact number of how strong the relationship is between these two variables. And we do this using a correlation coefficient. And this ranges from -1 to +1, with 0 being no correlation, as you may have guessed. So in this example, this is a positive correlation. As energy level increases, compliance with yoga routine also increases, and vice versa. As energy level decreases, compliance with yoga routine decreases. But how strong of a relationship do these two have with one another? Well, as we can see here, they have a +1 correlation, a perfect positive correlation. So that would indicate that yoga sessions are always accompanied with high energy, and vice versa. However, a perfect negative correlation would be indicated by a -1. So this is a perfect negative correlation. Keep that in mind. These two, fairly simple. Perfect positive correlation, +1. Perfect negative correlation, -1. No correlation at all, 0. So the coefficient measures both the direction and the strength of the relationship. So ranging from -1 to +1, and the absolute value of the number is the strength of the correlation. So a -0.8 is a stronger correlation than a 0.2. Even though it's negative, it's still a stronger negative correlation than is +0.2. +0.2 is actually closer to no correlation at all, and it could have just happened by chance. So keep that in mind. Now, just because two things are related and have this relationship with one another does not mean that one is causing the other to happen. Sometimes that could be the case, but a lot of times it's not. And the news channels, they play into this big time. They're always saying, well, these two are correlated, and when this happens, this happens. But they're not saying that one's causing the other. They're leaving that part out because that doesn't make good news. So if you think about it, there's got to be something else that's doing this. Let's give an example. In this case, watching violent television programs is positively correlated with aggression in children. Does this mean that the television programs are actually causing this aggression? Well, as you can see, there's 3 possibilities to this answer. 1, that is the case. Watching violent programs causes aggression. 2, aggressive behavior causes children to watch violent programs. That could be it too. Or there could be a third variable that's causing both. Take a second to think, what could that possibly be? If your guess was parenting, then your guess was highly accurate. The third variable for this relationship between watching violent television and being aggressive could possibly be due to the fact that these children have a lack of adult supervision. So a lack of adult supervision is very likely to lead to you watching a violent show. If any of you can think back to when you were a child and your parents left and you were like, yeah, finally get to watch Saw. Or whatever it was. It was The Ring for me, I think. But you're also going to be more aggressive if you don't have adult supervision and they're not in there creating rules and teaching you social boundaries. So the third variable between the relationship of television and aggression is lack of adult supervision. Let's look at another one. Once again, NBA. So studies show that NBA players that wear shoes with their name on them score more points than players that don't have their names on their shoes. I apologize for the typo. For example, Jordan and Durant. Okay, so this is a correlation. This is a correlational relationship. These two are related. Is one causing the other? Are the shoes causing them to score more points? Well, let's hope you said no, and let's hope what you've gathered is that it's probably the fact that they're great players, and great players get shoe signing deals. And so one is not causing the other. They're merely related in a correlational way. And this one I want you to do by yourself. Studies in Taiwan have shown that there is a strong positive correlation between the use of toasters and contraceptives. Now take a minute and jot down what you think this might be. What is the third variable that's causing this? Because there's no way that these two are causing one another. So what's the third variable causing this? Okay, hopefully what you guys have come up with is something to do with the fact that, something to do with finances, the fact that people with more money are able to buy toasters. they're also able to buy contraceptives. So you could probably look at it with any major appliance in their kitchen, and it's going to be correlated with the fact that they're taking birth control. It's a financial third variable. Good job if you got that right. Just some anecdotal, other strange correlations that are occurring. The poorer the country, the larger the size of a man's penis. That is a negative correlation. When one goes down, the other one goes up, basically. No pun intended. A pirate shortage has led to global warming. Well, pirates have decreased in the last 100 years. I don't know if anyone told you. And global warming has increased. A negative correlation. But one's not causing the other. Increased ice cream consumption leads to increased murder. A positive correlation. Ice cream is actually positively correlated with a lot of things. It's positively correlated with shark attacks, as well as diagnosis with polio. So, third variable, heat, summer. People are more active, more people die. And then age of Miss America, as that increases, the number of murders by steam and hot vapors also increases. So those two are positively correlated. And the number of people who have died from strangulation by their bed sheets increases as the total number of revenue of skiing facilities increases. I'm thinking that one, well, it's positively correlated, but I'm thinking that one's not causal. So, just to give you some idea of how ridiculous this correlation and causation mishap is and how often it actually occurs in the news. So watch the news later on and see if you can determine any of these correlations that they're giving us, but they're not giving us the actual information, the key factor that we need, which is that third variable problem.